Hello, we're going to do another math lesson. This is Unit 16, Probability and Data Management. This is lesson PDM8-21, Counting Combinations. Now this is found in your Jump Math workbook on page 202, 203. So you're going to need your Jump Math workbook. You don't need a calculator for this one because none of the math is that complex. So let's take a look at this first box here. Mickey wants to know how many outcomes there are for two games, or a game with two different spinners. He's got spinner 1, R and Y, spinner 2, 1, 2, and 3. So there are 3 outcomes on the second spinner, 1, 2, and 3. So Mickey lists each color on the first spinner 3 times. Beside each color, Mickey writes the 3 possible outcomes on the second spinner. So we've got first spinner R, second spinner Y, and then the second spinner outcomes of 1, 2, or 3. The total number of outcomes is 6. And if you did the T-chart lesson with me, you'll know that, of course, if there are 2 outcomes on the first and 3 outcomes of the second, the total number of outcomes is simply 2 times 3, which is 6 different outcomes. Okay, so let's check out question 1 then. Let's kind of blow through this lesson. For each question below, answer parts A and B, then list all of the possible outcomes Mickey can spin to find the total number of outcomes for each game. So let's check it out here. How many outcomes are on the second spinner? 1, 2, 3, 4. There are 4 outcomes. How many times should Mickey write W for white and R for red on his list? You should do them 4 times each because there's 4 outcomes for the second spinner. How many outcomes does this game have altogether? Well, the first spinner's got 2 and the second spinner's got 4, so the total number of outcomes should be 8. And we'll confirm that by creating our T-chart. Now this here is the T-chart. When it asks you to make a T-chart, they're looking for something like this. So first spinner, I've got to do each of these outcomes 4 times. And the reason I'm doing these 4 times is because there's 4 different outcomes for the second spinner. So my possibilities then are white and 1, white and 2, white and 3, and so on, all the way through the list. There's a total of 8 different outcomes. Do question 2 and question 3. Question 2 and 3 follow the exact same pattern, so I'll let you kind of do those on your own, and then we'll take a look at question 4 on the next page. Question 4. These are the choices at art camp: morning, painting and music; afternoon, drama, creative writing, or dance. Claire makes a choice so that she can see a chart, Claire makes a chart so that she can see all of her choices. She starts by writing each of her morning choices 3 times. Complete the chart to show all of Claire's choices. Now, they want us to complete the chart, and they've done morning column for us. So all we have to do is the afternoon column. In the afternoon, she's got a choice of drama, creative writing, or dance. Go ahead and fill in the chart for the morning and for the afternoon. Now, in the afternoon, she's got the exact same options if she chooses music as she does for choosing painting. One of these isn't dependent on the other. Now, looking at the chart here, I can see that there's actually 6 different outcomes. Okay, why did Claire write each of her morning choices 3 times? This is the morning. This is the afternoon. Okay, morning and afternoon. She wrote each of her morning choices 3 times because she has 3 options in the afternoon. 3 choices. Or sorry, 1 choice, 3 options. Okay. Now, again, the total number of branches is 2 options in the morning, 3 options in the afternoon, 6 different outcomes possible. Okay. I want you to do number 5 on your own. That looks like an easy one where we're doing a coin flip and a spinner. You can, I better do number 6 with you because I found that one a little confusing. Peter has a quarter and a dime in his left pocket and a dime and a nickel in his right pocket. He pulls 1 coin from each pocket. So each pocket then is a separate outcome. So we're going to make a T-table to show our outcomes. Okay, so we've got pocket 1, pocket 2. Now, pocket 1, he's got a quarter and a dime. Pocket 2, he's got a dime and a nickel. So there's 2 outcomes in the second pocket, which means I have to list the first outcomes twice. Quarter, quarter, dime, dime. In the second pocket, he could do a dime or a nickel, or a dime and a nickel. How many outcomes are there? Well, there's 2 coins in the first pocket, 2 coins in the second pocket, total of 4 possible outcomes. And you can see you get a quarter and a dime, quarter and a nickel, dime and a dime, or dime and a nickel. Those are all the different outcomes that Peter could get drawing coins out of his pocket. Number 7, you can do the exact same thing, create your own T-chart, but instead you've got 3 options in the first and 3 options in the second. Now, when you do that, you should end up with a grand total of, you guessed it, 9 different outcomes, because each one of these ones has to be listed 3 times for these 3 outcomes. Okay, let's take a look at number 8. Record all the scores you could get by throwing 2 darts at the dart board. If a dart lands outside the board, the score is 0. Okay, well, let's see. If I had 2 darts, okay, I could get 0 and 0, that'd be 0. And the maximum score I could get would be 6, right? Because if I got 2 3s, that would be it. So those are all the different scores. I could get 0 to 6. I guess I should list them instead of drawing an arrow between. So I'll just erase this here, and I'll list them like they've asked for here. 0, 1, 2, 4, 5, 6. Those are all the different possible scores that I could get. Find as many combinations as you can that give the same score. Okay, well, there's 4 different darts. Okay, there's 4 different numbers. I could get 0, 1, 2, or 3 with the first dart, and I could get 0, 1, 2, or 3 with the second dart. So there's a total of 16 possible scores that I could get, 16 different possible outcomes. Part C says, how many combinations give a total of 4? Okay, can you determine the probability of scoring 4? Explain why or why not. Well, I'm going to start off first by talking about the probability of getting a 4. And my probability of getting a 0 is not the same as my probability of getting a 3. It's much harder to get a 3 because the 3 is a really small circle and the 0 is anything outside the circle. So it doesn't really matter where I throw the dart outside the circle, I've got a 0. So I can nail those zeros really easily. The 3 is a lot more challenging. So first off, I can't accurately tell you the probability for these ones because they're not the same size. However, I can tell you how many scores add up to 4. Okay? And I think a T-chart is probably going to be the best way of explaining this one here. Oh, let me get the eraser out here. Let's do a T-chart for this one here. To make this one a long one. There's a lot of different outcomes. I better erase that. That's a sloppy pen. Okay. First off, I know that there are 4 outcomes for the second dart. 0, 1, 2, or 3. which means I have to list all of the first outcomes 4 times. So I need 4 zeros, 4 ones, 4 twos, and 4 threes. And then I need to write what I could get with the second dart. 0, 1, 2, 3, 0, 1, 2, 3, 0, 1, 2, 3, 0, 1, 2, 3. Now this is actually really handy to actually have different color markers, because then I can take and I can highlight or circle all of the numbers that add to 4. So I know that 1 and 3 add to 4, 2 and 2 add to 4, 3 and 1 add to 4, and that's it. Those are the only numbers that add up to 4 out of all the 16 outcomes. So out of all the different combinations, 3 out of 16 add to 4. Is that equally probable? No, because some of these numbers are larger than others on the dartboard. So I can't accurately predict probability, but I can say 3 of those actually add to 16. Let's take a look at number 9. A tetrahedral die has 4 vertices numbered from 1 to 4. When you roll this die, there's always a vertex on top. So when we're talking about a tetrahedral die, it's actually only got 4 sides here. Okay, it's like a triangular pyramid. Yeah, triangular pyramid. Make a chart to show all the combinations for rolling this pair of tetrahedral dice. Now, with a tetrahedral die, only one of the 4 options can come up on top. Okay, so it says make a chart to show all the combinations. Well, all the combinations are simply going to be anything between 1 and 4 on the first die and 1 and 4 on the second die. It's basically going to be a chart that looks very similar to the chart in the previous question. Okay. I would actually rather just say there are 4 options for the first die. There are 4 options for the second die. There's going to be a total of 16 different combinations that I can come up with. Now that's kind of lazy. It's not the same as actually drawing out the charts and seeing what everything adds up to. But I can tell you that there's going to be 16 different outcomes that I could roll with those dice, or 16 different possibilities. Okay? Without making a t-table, say how many combinations there will be if you roll a pair of regular dice. Okay? Well, a pair of regular dice, there's 6 different numbers on a dice, and there's 2 dice. So 6 times 6 equals 36. What about a roll of a regular die and a draw of a marble from a box of 35 marbles? Okay, so a regular die is 6 outcomes, 1 to 6. And the other one is any number of 35 marbles. So the number of outcomes that you could have is going to be much larger. 6 times 30 would be 180, and 6 times 5 is 30. So that is a total of 210 different outcomes that you could get if you're rolling a regular die and drawing a marble from a box with 35 marbles. Okay, that's the lesson there. Combinations mean that you have 2 different events and you're looking for the probability of, or the number of outcomes that you could have with these 2 events. So this is just all about the total number of outcomes, okay? Which will be really key for the next lesson, which is on compound events, which is the probability of something happening when you have more than one event.